In this lesson, we're going to talk about how Unity utilizes both C# namespaces and classes in order to organize the methods and functions we've been using to work efficiently. We'll also look back on some of the FMOD commands we've been using in order to gain a better understanding of how they work. First, let's remind ourselves a little bit about the roles of namespaces and classes. In our FMOD scripts folder, we're quickly going to open it up and we're quickly going to create a blank script just to demonstrate what we'll be talking about in this lesson. So once you've created your script, just call it something like blank script. Then once it's compiled, let's open it up to edit it. So if you remember back in the first C# basics lessons, we talked about the namespaces and main classes you'll see whenever you open a new script. To recap, the lines that start with the using keyword are namespaces. Namespaces are an organizational tool in C#, and these namespaces have been created inside other scripts. By using the word using before the name of each namespace, we're able to use any classes that were created inside of those namespaces in this script. Underneath the namespaces that we're using is the main public class of this script that shares the same name as the script itself. Now, as we already know, whenever we create a new script in Unity, we're automatically given a class for that script to write everything inside of. Now, every class created in this way in Unity derives information from another class called monoBehavior. Now, monoBehavior is a class that was created by the Unity developers and is pre-programmed using C# to allow us to perform game-related actions when our game is being played at runtime. This allows us to use functions and variables that were created within monoBehavior inside our scripts. So for example, we're able to use both the start and the update function because we're deriving them from monoBehavior, which allows us to perform tasks on the first frame and on every frame respectively. Whenever we create a class that we wish to derive information from another with, we simply follow it with a colon and the name of the other class, which Unity will do automatically for us here. Now in Visual Studio, we're actually able to take a look inside classes created in other scripts. We can do this by right-clicking on a class and selecting Go to Definition, which will allow us to see everything that was created inside the monoBehavior class. We can also do this by holding down the Control key on our keyboard and by clicking on the class name. As you can see, the monoBehavior class is laid out and structured in the same way all of the scripts we've been creating are as well. At the top are all of the namespaces that the monoBehavior class is using. Inside the class are functions and methods being used for different purposes. We can click on one of the plus symbols next to one of these methods to get a summary of how they work and what their purpose is. Now, one of the main differences between this class and the ones we've been using is that at the top here is you can see that the class itself was created inside the namespace Unity engine, indicated by the class name being inside the body of the namespace. This means that if we wish to access any information from the monoBehavior class, we need to use this namespace, and if we go back to our blank script by clicking on its name in the top left, that's exactly what our script is doing, as you can see at the top here. Now, if we were to remove the Unity engine namespace from the top of our script, we would no longer be able to derive information from monoBehavior as indicated by the red squiggly line underneath it, giving us an error. So let's quickly undo that so we make sure we don't get an error. Whenever we want to create a namespace, we simply write the keyword namespace followed by a name we give it, starting with a capital letter, and then give it a body. Inside the namespace, we can then create a class in the exact same way. Now notice how I created the namespace outside of our main class up here. This is because you can't create or declare a namespace inside of a class. So now, if we ever wanted to use the test class, we'd have to first declare that we are using the test space that it was created in. So if we wanted to, we could declare our blank script class inside of a namespace. All we'd have to do is make some room, declare we are creating a namespace, give it a name, give it a body, then highlight our class and everything it contains, then simply cut it, and paste it in the namespace. If we go back into monoBehavior, like we established earlier, you can see that the class itself is being created in the Unity engine namespace. If we take a look at all the namespaces it's actually using, we see that it is also using the Unity engine namespace as well as creating it. This tells us that the Unity engine namespace is also being declared somewhere else in another script, and that's okay. It now means that whenever we choose to use the Unity engine namespace, we can use both the monoBehavior class that was created here, as well as any other classes created inside this namespace Unity engine from other scripts. The last interesting point to note about the monoBehavior class is that it is actually deriving from another class called Behavior. So if we click to open that class up, we can see that it also derives information from another class. We can then keep going through each of these classes until we get to the last, and notice how all of which were also created inside the Unity engine namespace, meaning that we'd be able to access any of those classes back in our blank script if we wish to. Now, the last thing to note on Unity related to classes and namespaces is that Unity will sometimes add namespaces automatically to your scripts that you won't need to use. If we take a look at the two top namespaces in our script, both of them are tinted grey thanks to Visual Studio, meaning that they are currently not being used in this script. So if you find yourself not putting them to use, feel free to remove them in order to simplify your scripts a little. Awesome, so now that we've looked at how C# namespaces are used by Unity, it's time to see how FMOD, and by extension we, can utilise them ourselves. Now, so far we've looked at many different FMOD commands that can play, stop, change and affect our FMOD events in our game, while most of them are utilising C# namespaces and classes in order to work. So let's quickly create a public string in our main class, which we'll call EP, short for event path. And in our start function, we're going to write fmod unity.runtimemanager.play one shot, and then use the event path and the transform component to tell it what to play and where. So up until now, we've been treating this command, amongst others, as one whole entity. But if we hover our mouse over each individual part, Visual Studio's IntelliSense will tell us what they are. And we can see the first is a namespace called FMOD Unity. The second is actually a class called Runtime Manager, called inside of the FMOD Unity namespace. And the last is actually a function created inside the Runtime Manager class. So really, play one shot is actually a function that we're sending arguments to through its parameter brackets and was declared inside of the Runtime Manager script, which in turn was declared inside the FMOD Unity namespace. Now to take a look at this script, we could right click on the Runtime Manager class and select go to definition like we did before, but instead we're going to find it another way. Now when we installed the FMOD and Unity integration package into our Unity project, we downloaded and installed multiple C# scripts created by the FMOD development team for us to reference in our scripts. These scripts are what make up the FMOD Studio API. All of the FMOD commands we've been using so far were created inside of those scripts. So to find them, we first need to find the location of our Unity project folder in either our PC or Mac, depending on what it is you're using. Now, in my case, I stored it in a folder called Unity Projects in my Documents folder and called it 3D Game Kit. So I'm going to click on my Documents folder. I'm then going to go to Unity Projects. I'm going to select the 3D Game Kit Unity project. Once you've found your project, open it up and navigate your way through the Assets folder, Plugins, and the FMOD folder. Now it's in here that you will find all of the C# scripts that our Unity project is using in order to play our FMOD events. Now in the case of the play one shot command, we want to open up the runtimemanager.cs file with either monodevelop if you're on Mac or Visual Studio if you're on PC. So to find it, we need to go src runtime and then select the runtimemanager.cs file. Now that we've opened the script, we can already see similarities to the scripts we've been writing. At the top, we have namespaces that the script is using. We can also see a namespace being declared called fmod unity, which we know is the first part to creating our play one shot command. Now inside this namespace, we have the main class runtime manager. That's deriving information from monobehavior as well. Then, if we hit Control F and search for play one shot, we find two functions called play one shot. So to quickly explain why this script actually has two play one shot functions, the first is the one that we are calling upon each time we write it in our script. We can tell this because in its parameter brackets, it has a string variable as well as a vector-free variable, which matches up to the information we feed it whenever we use it. It then checks to see that the event path we've given the function exists, and if it doesn't, it will send an error message to the console tab. If it does exist, then the second play one shot function is called from within the first. Now it's in here that the event is actually played, as we can see the instance being created, the 3D attributes for that instance being set, the instance being told to start playing, and finally being released, just like we've done in the past with our own instances. Now you might be wondering at this point why it is important to know all of this. Well, depending on how big your scripts get and how many times they are using functions from classes that use namespaces, we can call these functions more efficiently by stating which namespaces we're using before we write out our functions. So let's quickly jump back into our blank script to demonstrate this further. Okay, so let's say that inside this script we need to trigger multiple play one shots. Now ideally we don't want to have to write the FMOD Unity namespace each time we want to use the play one shot function. So instead, at the top of the script, we're going to say that this code is using the FMOD Unity namespace. Now notice how both the namespace at the top and the namespace in our function have both been grayed out. This basically implies that it doesn't need both of them and you can use one or the other. So what we're going to do is delete the namespace before we wrote runtime manager and declared the class. And there we go, now it's colored white. So now we can create multiple one-shots and we don't need to write FMOD Unity in front of any of them. We can also do the same with any event instance we create ourselves. Let's first remind ourselves how we would normally create an event instance. So inside our class, we'd write fmod.studio.eventInstance and give it a name. Then inside the start function, we can set an instance to it by writing runtime manager dot create instance and then enter our event path. And notice how again we don't need to write FMOD Unity in front of runtime manager as it's already been declared. Now if we take a closer look at our event instance at the top of our class, we will notice a similar pattern to the play one shot function. Starting with the first part, we can see that FMOD is actually a namespace. Moving on, we see studio is also a namespace that was created and declared within the FMOD namespace, which we'll look at shortly. And finally, event instance is actually a struct. Let's quickly take a look at the event instance struct by going to its definition, finding where it was declared. Now in this instance, a C# struct is something similar to a class, both of which are important concepts within what's known as object-oriented programming, or OOP for short. A struct is another way of grouping a bunch of data or variables in one place, in a similar way to how we might in a class. We can then create an instance of that struct and set values to its variables. So whenever we create an event instance inside one of our scripts to store an event path inside of, we're essentially creating another instance of this specific struct. So obviously here we can see this was where the event instance struct was first declared and created. Now a lot of C# concepts that we have not yet discussed are being declared inside of this struct, so we won't look at them in too much detail for now. But what's important for us to note is that a lot of commands we've been using for our event instances are being set inside of this struct. For example, if we scroll down a bit, we can see the start, stop, and if we scroll down a little bit more, we can see release as well. What's handy about looking at events instance in this way is that we can actually see what each of these commands require to be used. So for example, set volume, which is something we'll be looking at a little later on, requires a float value to be used when setting volume. Now if we move our mouse over to the dotted lines to the left, we can see the struct that these were all declared in, but then if we move over more, we can see the namespace that the struct itself was declared in. Now, unlike most of the code we've been writing so far, this struct was not created inside of a class, as they don't need to be. However, it was created inside of a namespace. So let's scroll up to the top of our script to take a look at the namespace itself. So if we scroll to the top, we should see that it was declared inside of two namespaces, separated by the dot operator. Now this means that the studio namespace is also being created directly inside of the FMOD namespace. Therefore, if we wish to use anything that was declared inside of these namespaces, we must write both of them in our script as opposed to just one. Another way of writing that would be like this. We could create the studio namespace under the FMOD one and have all of the structs, classes, and etc. created inside of the body of the studio namespace. Creating a namespace within another one is usually done for more control over organization. If we go back into our files and open up the wrapper folder and then the fmod cs script, we can see that this script only uses the fmod namespace. So this means if we wanted to use anything from this script inside our blank script, we'd have to write using fmod at the top, like that. Now in the case of our event instance, which was created inside of the fmod studio script, we instead want to write both the namespaces that it was declared inside of. So let's add studio to the end of the FMOD namespace. Now we can remove the two namespaces from in front of event instance, and we could continue to use this script and it would work as it normally would. And there we go! We now have a better understanding of where our FMOD commands come from, how to use them, and how to shorten our scripts by utilizing namespaces more efficiently. We've seen how other classes are made inside namespaces and what that means for us when using them. We've seen scripts made by the FMOD developers, such as the runtime manager script, and learnt how we're actually using functions that were declared inside those scripts. We also know how to shorten our FMOD functions and commands the next time we use them by declaring the namespaces that they require at the top of our scripts with the using keyword. So as we continue on, we'll be looking into some more C# concepts that the API uses and how that affects our coding. So now that we've discussed namespaces, feel free to go back to the scripts we've already created in previous lessons, maybe add some of those namespaces to the top of them, and see how using those shortens your scripts and makes them more efficient. Once you've done that, take a well-earned break, and I'll see you in the next lesson.